All right, hi guys. Here's the quick overview of the day 2 log notes. So yesterday we talked about the fact that just like dividing undoes multiplying, right? A log undoes an exponent or undoes exponentiating. Right, which is going to be a term that we talk about. So I just want to do one of these. 6 squared, you know that that's 36. So to evaluate log base 6 of 36, what I want to do is take 6 squared equals 36. And let's actually take the log base 6 of both sides. Now, when we do that, log base 6 of 6 squared, and then over here, log base 6 of 36. This, on the right-hand side, now matches what we're trying to evaluate. On the left-hand side, that part cancels, and what you're left with is just plain old 2. So that's how I know that log base 6 of 36 equals 2. Okay. And now, if this were a longer overview, it'd be different. But what I want you to recognize is what this is equal to. The 2 here, that is the exponent over here. And that's always going to be the case. So if we fill in what the other ones are, 10 to the negative first power should just be 1 over 10. Well, that means that 10 log base 10 of that 1 over 10 should be equal to the exponent right here of negative 1, and so on. All right. So the rest of what we are going to look at is just the idea of how to move back and forth in between the two forms. So to write an exponential equation in logarithmic form, you would just simply take, I'm going to say log base b, so whatever the base is, of both sides. So like if I have 2 to the 4 equals 16, to change that into logarithmic form, I would do log base 2, because that's the base I've got here, of the left-hand side, do log base 2 of the right-hand side. Okay? All of this part of it cancels, and so what you end up with is just plain old 4, and then on the right equaling log base 2 of 16. So something to keep in mind, this equation and this equation, they both actually mean the same thing. They're just written in exponential form here, logarithmic form here. So to go the opposite direction, to go from a logarithmic equation to exponential, we're going to say that we exponentiate, right, both sides of the equation. So here, to get rid of log base 2, we're going to use the 2 there, and we're going to do 2. We're going to raise the left-hand side to it, and do 2, and now raise the right-hand side, right, to 4 there. So this piece of it, that cancels. So see you later. You're left with just the 16. On the right, what you're left with is 2 raised to the 4th power. So here I use the little carets. Here now I can rewrite it without the little caret notation. All right. So exponent both sides of the equation. Oops, I should fix that with the base of the log. All right. So the big idea, they are inverses. A log undoes an exponent undoes a log. All right, so jumping on down here, for each one of these, when it just says write each exponential equation in logarithmic form, nothing crazy. Just remember, use the base that you've got. So like if we use this middle one here, the base would be the 9, right? So then we would do log base 9 of 9 to the 1/2 of the left, log base 9 of 3. So keep the base the same on both sides. This cancels, and now here it is in logarithmic form. So that means log base 9 of 3 equals 1/2. You can do the same thing with the other two. As for the other ones. Now it's asking you to go the other direction. So this is a little new. Write each logarithmic equation in exponential form, right? In that case, here's where we're going to exponentiate on both sides. Here's our new term. I always think it sounds made up, but we go with it. So for the very first one, the base that you have is 4. So that's what I want you to stick with. You're going to do 4, and then raise it to the power of the whole left side. Do 4, raise it to the power of the whole right side. That cancels, and so you just get 16 equals 4 squared. Make sure when you get to this step that that actually makes sense. So 4 squared is 16, we're good to go. All right. If I jump, let's say, to the last one, this would have a base of 3, right? And so that's this guy right there. Oops, I just kind of killed it. All right, but the idea is now do 3 and raise it to log base 3 of 27, and then do 3, raise it to the 3 on the right side. This part of it cancels, so you're just left with 27 there, equaling 3 cubed, which makes sense, and you're done. The next part, solve each equation for x. So since you're in logarithmic form, right, what we're going to do is we want to get rid of the log. So the goal is to eliminate the log, which means we're going to exponentiate to do that. All right, so that's how we're going to eliminate it. So for the first one, our little base is 3 here. And you don't really have to write it down. I just want to make sure it's clear. So on the left-hand side, I'm going to do 3 raised to the left, 3 raised to the right. This part cancels. All I'm left with is x, and then equals 3 squared, and then 3 squared is just 9. Done. Okay. Some of these are a little trickier depending on where the x is. If I look at one like, let's see, part C, the base would be the x. So you're going to do x raised to each side like that. This would cancel. I get 16 equals x squared. The only tricky part about this is when you take the square root, technically you'd get plus or minus 4, right? But we're only going to keep the positive, because what you'll find out is that you cannot have a log of anything negative. You also can't have the base as anything negative. So you're going to keep just the positive 4 here. Okay? Try the other two, though. You can always check the answers with the solutions that I post on the website. All right. Evaluate each logarithmic expression. All I'm going to tell you here, set them equal to x, and then you can take it from there. So exponentiate. And G8. All right. So I'm going to say set equal to x, and then exponentiate to solve. So if I set this guy equal to x, and do 2 raised to the left, 2 raised to the right, you get 8 equals 2 to the x power. You can either think about powers of 2 or rewrite it using common bases. That's what your whole last unit was, talking about. So this would be 2 cubed, 2 to the x, so x has to be 3. And you can do that with all of these ones. And then the last ones are just asking you to evaluate. So even though it says evaluate, it's still the idea that you can plug in. So like the first one, if we're doing f of 243, you get log base 3 of 243, right? Feel free to set that equal to x, and then exponentiate from there. So I don't really need to see that piece of it. You can now say, all right, let's do 3 raised to the left, 3 raised it to the right. This part's gone. So we get 243 equals 3 to what power?
Oh.
You got to think, what power of 3 is 243? You may have to mess around with that on your calculator, or just type this into Y1 and take a look at the table, but take a look at those powers and then you can figure it out from there. I think it's 5, but I don't have my calculator sitting in front of me, so don't quote me on that. Great. I'll let you fill in that blank. All right. Otherwise, I think that's it. I think that's a fast enough overview of what I need you to know. See the full notes online, right? And hopefully I'll see you tomorrow in class. Thanks, guys.